All right. This lesson is based off of that. You understand 2D vectors. You've done dot product. You understand the magnitude. Here we go. So when we're talking about 3D vectors, really what we're doing is we're just adding an extra dimension on this one. So we have x, y, z. You can decide, but you're going to see me pretty consistent, is I make this x, y, and z. As long as you're consistent with your own, you're fine. I'm also going to make this the positive x, this is the positive y, and this is the positive z. So in other words, if I wanted a vector that went 4 on the x, I wanted -2 on the y, and 5 on the z, it would be going in this direction. That's tough to see, so I'm attempting to show you the same thing here. So you can see here that it's 4 on the x going left and right. And also, let's see if this works. Nope. 4 on the x, 2 on the y, and you can see if I rotate this, that's what the vector would look like. Okay, so that being said, it's going to be one of the toughest things to think of it as three-dimensionally. So a lot of times, to let you be able to see it three-dimensionally, even though I'm only drawing 2D, I'm going to use a box as a reference. So if I need to talk about vector CG, and once again, I'm going to make this positive x, positive y, positive z. Same direction as this. So if I start at C and go to G, what's the only axis I'm actually moving on? What would be the vector on this? So CG should be, since I'm only moving 6 this way, and that's my y-axis, I'm moving at -6, but I'm not moving at all 0 and 0 on my x or my z. So CG would have to be 0, -6, 0. CH. So if I go from C to H, well, I still have to go -6 on the Y. That would get me to G, but now I got to go on the H. And since H is the same as my X direction, but in a negative way, I went -4 that way, and 0 on my Z. DF. What would that one be? Well, starting at D, I need to get to F somehow. So I need to go 4 on my X. I'm going to have to go up to my B, so that's 3 on my Z axis. And finally, to get back on F, I have to go 6 that way, but I'm going in the -6 direction. So it'd be DF is 4, -6, 3. So that's how we can create these vectors. So DF, see if I can do this, would be a vector that's going that way. Tough to see. What is vector CE? Start at C, end at E. So we can go back -6 on the Y, -4 on the X, up 3 on the Z, so that's vector CE. What's this? Well, that's the magnitude, and here's my point being on this one. If I wanted to find the magnitude of C to E, well, that's tough. I can find this magnitude, no problem, because this one is 6 squared. This is 4, so this distance here is 6 squared plus 4 squared. Take the square root of that. That's this length. This height is 3. So far, if I did Pythagorean again, I would do the square root of 6 squared plus 4 squared. I would square that plus 3 squared, and it's the square root of that. Okay? In other words, this is the square root of 36 plus 16 plus 9. Or, short version is, it's basically the same. It's a Pythagorean theorem just with an extra variable. So if I gave you this vector again, and I asked you what's the magnitude of that, what would it be? Well, it would be the square root of 16 plus 4 plus 25. In other words, the square root of 45. Okay. Given that vector AB is the following, I tell you that P is 3/4 the distance from A to B. What is AP? Well, it's really, short version is 3/4 times 4, -8, 12. This goes back to our scalar multiplication. If you want to simplify, you could take 3/4 times the 4, get you 3. 3/4 times the -8, get you -6. And 3/4 times 12, which would get you 9. Either answer would be correct. Dot product works exactly the same as well. Not bad to take this down as notes, keep track of this one. What it looks like is this. If I had vector AB and vector CD, then cosine of theta equals 4 times -1 plus -8 times 2 plus 12 times -3 over the magnitude of AB, 16 plus 64 plus 144 times the magnitude of CD, 1 plus 4 plus 9. Or in other words, if I simplify, I get the inverse, or the cosine of theta equals -56 over the square root of 224 times the square root of 14. At this point, we'd go to our calculator. And you can see here that to solve for that, I just have to do the inverse cosine of -56 over, notice the brackets on this. I have the whole denominator in brackets. Get the answer to this, or it's going to spin and ruin this whole thing. So I'll just grab my calculator while it's freaking out. Inverse cosine -56 divided by square root of 224 times the square root of 14, 180 degrees.